graveyard shift. My fellow speakers and I are very appreciative. So starting off, I want to invite everyone to imagine that you're an investment analyst and it's 4 in the afternoon and your investment colleague emails you to say that they have to take a project to the investment decision committee next week. They're so sorry for the short time frame, but is there any way you can do a quick review of any publicly available information about the company to make sure that there are no red flags? In fact, they even have some of this information handy, like the most recent annual report that they can send over if that will help. You say, okay, you'll do your best to make it happen and open the email they send you with a 700-page attachment. My colleagues and I frequently face this dilemma. We work for the Environment, Social, and Corporate Governance Department of the International Finance Corporation. My name is Atya Karmali, and I work alongside 200 other experts who cover a variety of issues like climate change, biodiversity, and corporate governance. The International Finance Corporation is a member of the World Bank Group and is the world's largest global development institution focused on making investments through the private sector. This past year, we invested almost $33 billion in companies in emerging markets. And when making investments, we look carefully at the sustainability impact of a client's operations and consider a multitude of issues, like their track record for worker safety, methods of pollution prevention, or approaches to engaging stakeholders. And working with clients to meet their financial, development impact, and sustainability goals continues once they are in our portfolio through input from a team of experts with specialized knowledge. But let's go back to our investment analyst, who is beginning on page 1 of that 700-page report, because successfully delivering this investment strategy means analysts must review between 10 to 20 documents a week, often many pages in length, and frequently filled with technical jargon requiring subject matter expertise to understand. In other words, the amount of information you have to review can be vast, and often you only have a few days, and on one recent occasion, hours, in which to make this happen. And this scenario is not unique to my colleagues and me. This is a common dilemma also faced by many in the audience, like academics, policymakers, and data analysts. We all know the feeling of too much to read and not enough hours in the day, and are left asking, how do you balance this review of reams and reams of technical text with the need to respond rapidly and efficiently in support of your institution's needs? Now imagine you have a colleague who never gets tired, never sleeps, and can read 19,000 sentences a minute. Meet Milena, or Machine Learning, Environment, Social, and Governance Analyst. Milena is an artificial intelligence, and Milena has been taught to read documents and find issues of relevance to my colleagues, like the amount of water a company used in its operations, or the number of women members on a company's board, or any risks the company posed to the health of communities in the past year. Not only does Milena tell my colleague where a word or phrase is found in a document, but Milena also gives her the context or sentiment in which these words occur in a sentence. For instance, Milena tells her if the words water consumption are found in a positive context, in a sentence that says water consumption has decreased in a company's operations. Or alternatively, Milena tells her if the phrase women on the board is found in a negative context, if a sentence says a company has not achieved its board diversity goals. This helps my colleague understand what a company is doing well, or where they are having problems, and get to the important stuff quickly so she can get on with making her investment recommendation. How does Milena do this? Milena is based on a technology called natural language processing. Natural language processing is a branch of artificial intelligence that allows computers to understand written and spoken language, or in other words, to read and listen to words or text. First developed in the 1950s, the technology has become very sophisticated in recent years, thanks to advances by Google and Meta, and most recently, OpenAI, and its much discussed and debated ChatGPT chatbot that uses a type of natural language processing to generate text. Big technology firms frequently make their artificial intelligence applications available for exploration, adaptation, and even improvement by others. And Milena is based on an open source model first developed by Google in 2018 called BERT, which was later refined by Meta. And it's access to such open source artificial intelligence applications together with cloud computing that has made in-house development of specialized applications like Milena that much more accessible to institutions like ours. In fact, institutions like the International Finance Corporation are particularly good laboratories for developing these types of specialized applications because these institutions have what such models love, and the reason we're all here today: data. Being in business for nearly 70 years means the International Finance Corporation has generated a lot of data. Much of this is stored in Word documents and PDF files. Exactly the kind of data these types of models excel at analyzing. Even better, this data can be used to teach models, like BERT, specialized subject matter knowledge, also known as fine-tuning a model. This is particularly useful for subjects with a lot of dense technical jargon, like medical terms, legalese, or in the case of Milena, over 1,000 environment, social, and corporate governance topics. We started building Milena in 2019, and over the past 4 years have used documents going back to 2001 to create 150,000 examples of training data to teach Milena the meaning of terms like greenhouse gas emissions, board composition, or biodiversity management plan. As of date, Milena has read almost 250,000 documents and created insights for 10,000 companies in 186 countries in 26 sectors. We've already talked about one of Milena's strengths, which is understanding context. Understanding context has allowed Milena to identify 15 million risk terms from all the documents it has read and to classify these as positive, negative, or neutral. And why is this of value to you? Classifying risks saves time reading and organizing information, gives you a head start, and helps you understand what a company is doing well or what they may be struggling with. Milena's other big strength is speed. It can read 19,000 sentences a minute. Documents like that 700-page annual report are analyzed in the matter of minutes. And after scouring documents, Milena structures the insights and generates dashboards on sustainability performance. These dashboards make the relevant information easy to find and display results through different lenses like document or sentiment or risk type. What does this help you do? At the press of a button, users can unlock curated information from many lengthy documents, PDFs, tables, running into thousands of pages, disregard the non-essential information, and focus on what matters. This helps you make better informed decisions, and this has been a game changer to how we do business. For instance, we have been able to help our colleagues reduce the amount of time it takes to compile an insightful company profile from weeks to half a day. And while this has increased productivity and reduced errors, it has given our experts more time to do what humans still do better than machines, which is unstructured problem solving, or thinking creatively and innovating to find answers to problems for which the rules do not exist. So what does this mean for you in the audience? While initially conceived as an in-house solution for our experts, Malena is in beta testing with other users. This is because we plan on making Malena available for use externally in summer this year, a full year ahead of schedule. And we are racing to get Malena out as quickly as possible in order to meet a key challenge to the Sustainable Development Goals, which is the gap in sustainability data. This data gap has been identified as a blocker to making sustainable, long-term investments, especially in the parts of the world where development needs are the greatest, and as a consequence, the gaps in the global goals are the most significant. This impetus to share Malena is also motivated by research, both our own as well as that of others, that finds news, impact reports, and corporate disclosures like bond prospectuses were underused by investors when assessing the sustainability performance of companies in emerging markets. Often because investors just don't have the in-house capacity needed to review all this information. Therefore, by using Malena to read and structure this underused information, investors can now easily assess these companies that went uncovered. But why does this matter to the Sustainable Development Goals, and how might this matter to you? The funding gap to meet the global goals is estimated at $2 to $3 trillion annually. While that sounds like a massive number, wait for the next one. In contrast, there are almost $200 trillion invested in capital markets globally, a small percentage of which, if redirected, can help meet this goal. And Malena can help make this happen. I imagine some of you may have concerns about using an artificial intelligence tool. This is why trust, as we've heard many times over the course of the forum, is critical. Users and stakeholders must trust that their privacy is respected, their data is used transparently and responsibly, and stored securely, and that technologies like the ones Malena is based on are adopted in an equitable and inclusive manner. To ensure this, we are developing a data and model governance framework covering ethics, fairness, and explainability, or transparency around how Malena makes decisions. This is to increase trust and confidence in Malena's predictions and ensure Malena's outcomes can be easily interpreted by the end user. So, how can this help you find what you need in your version of that 700-page report? In less time than it took me to explain Malena to you, Malena scanned that document for my colleague so she could make better investment decisions. I hope you will consider doing the same and join us with beta testing. Thank you.
You can directly start.
Thank you. Hello, everyone. Thank you to join us. Let me introduce myself. I am Daniel Barraez from UNDP Venezuela Country Office. When we talk about monitoring new and old basic services using social network, specifically Twitter, the first question that arises is why monitoring basic services is relevant. And the answer is simple. Basic services are key for development for several reasons. Evidence of that is the basic services are transversal to SDG. Not only the SDG directly related to energy, water, but other ones like inequality or sustainable cities. So for the achievement of SDG is crucial and universal and good provision of basic services. Monitoring basic services is a way of monitoring SDG. On the other hand, basic services is a fundamental component of social contract. Citizens expect that governments provide basic services. From a governance point of view, a good provision of basic services is at the same time a requirement and an indicator of good governance. We cannot achieve a good governance without an universal, a good provision of services. New services are becoming basic services and are generating new inequality gaps. Internet access and digital world access are clear sources of new inequalities. Other important argument for monitoring is that deficiencies in basic services provision especially affect the most vulnerable population. Electrical power and safe water are clear examples. So if we want to put in practice leave no one behind, it's necessary to have a good and universal basic services provision. Besides, the basic services monitoring is useful for policymakers because the monitoring provides relevant information for maintenance and investment in basic services, especially a level of design and implementation of infrastructure, but not only for development in emergency or disaster context or humanitarian aid, the monitoring basic services provide us valuable information. Additionally, monitoring also provides information to identify vulnerable population. This is the population, in this case, that not have access or have poor access to the basic services. An important point of this work is this work is about perceptions. Monitoring social network is essential for monitoring the public perception of provision of these services. The perceptions are crucial for policy because a bad perception of a public policy made this policy unpopular, unsustainable, and unsuccessful. Other important question that we need to answer is why Twitter? Why to use social network? Because Twitter is not a representative sample in the traditional statistical mean, but many relevant actors use this social network to express themselves on public issues. And the complaint of these services is no exception. The heads of senior government officials, political and social leaders, parliamentarians, NGO, influencers, media, yet citizenship are all talking about his perception of public policy. These actors are fundamental in shaping the public perception. The big data and machine learning allow us to process information for social network timely and at lower cost than a traditional statistical surveys. We can work in any frequency, monthly, weekly, daily, and even online. Well, how does it work? Basically, we build an index of quality service provision service by counting tweets reporting shortage or complaint failure of these services. To show how this work, I will talk about a simple way of the workflow. The first step is the work on social network data source. In our case, we worked with PowerTrack Twitter API. The work consists of identifying tweets that report the failure in a specific service. We achieve this using dictionary of keywords. We will give next some example. The second step is to transfer the identified tweet from Twitter database to the UNDP cloud and check if the tweets are really reporting failures. This is a step key. The most important because the natural language may be unclear or misleading. For example, in some countries, we have found the expression no power, no energy. At first glance, it looks like a tweet reporting electrical power failure, but it's a comment of the lack of physical training of soccer team. It is a criticism of the team. So you need rule to include tweets and you need rule to exclude tweets. In NDP Cloud, we process all the database using text mining techniques and build the matrix on the default services. And then we proceed to identify the municipality where the failure occurred. Then we combine the index of failure with the localization and municipality label and obtain the maps. The last step, we deploy all the metric and heat maps in Power BI dashboard in a monthly or weekly frequencies. Here are some examples of keyword. The dictionary. The dictionary, you use the dictionary for both. For failure, for identification of failure, and municipality identification too. We don't use, this is a simple example, and Mickey Mouse example. We don't use single words. That don't work well. we use word combination. For each service, we have database containing between 100 and 200 phrases to identify failure. In a similar way, we construct a database with the official names and the main city of each municipality or state to identify municipality where the failure happened. Here are some examples of metrics. In the top panel, we have the failure in a specific month. As you can see, the electrical power provision is the main source of failure, followed by water. In the lower panel, we can see the evolution of failure index in a year and its moving average filter. In the left panel, we have monthly, this is another, the next slide. In the left panel, okay, we have monthly variation of the index. In the middle panel, the share of each basic services in the total of all failure that is clear dominated by electricity and after water. An analytic of interest is the notion of the critical municipality. A municipality is critical if it has an unusual level of failure at a given time. The level can be determined by the number of failure faults per capita or if it exceeds a given percentile of the failure time series, historical time series. Here, we can see in the top panel that in July and August, there were almost no critical municipalities, but September and November, it increased considerably because there heavy rains. In the below panel, we can see when months and municipality, the months when municipality remain critical. Finally, we have a heat map of the whole country at municipal level, showing which services has most failure for each municipality. It's clearly dominated by the yellow color, electrical, followed by water, and some cases of public transport in dark blue. Of course, we can build different types of map. A dashboard with all the analytic and maps is available in Teams Power BI. Only an UN email account is required to access the dashboard. The paper with the details of the methodology is available on the UNDP Latin American and the Caribbean website. There is a link in Hoover to the paper too. Many thanks to organizers, UNDP World Data Forum and the host country institution, the National Bureau of Statistics of China for the excellent organization of the event. Thank you for your attention.
can you hear us? Yeah, we can see your screen and you can see your video. Sorry, we can't hear you. You can start speech.
Good morning. Can you hear me now?
Yes, you can start.
Okay. Okay, give me one moment, please. I just go back to my presentation screen. Good morning. Good morning, good afternoon, good evening. Jia Shanghai, Xiao Hai, Wan Shanghai. Sorry I can't be with you in person in Hangzhou. De Buchi Wu Bang Xinga Shanghai Yu Ming He. And thank you both to Atia and Daniel for the previous presentations. Very interesting and very innovative to hear from the different corners of the world. So my name is Eric Deben and I work for the Office for National Statistics in the United Kingdom. And I'm going to provide over the next 20 minutes an overview on the machine learning and the data science revolution, the value of machine learning for official statistics, international experience from the UNECE Machine Learning Group. I talked through a few use cases. I also like to give you some lesson learned and also what's the next steps in machine learning for official statistics. So machine learning is evolving very rapidly. As you can see, there ML and AI are already part of our everyday lives, as we heard many times over the last few days. They run many aspects of a digital world, from the apps on your phone to social media and streaming services. Machine learning gives computers the ability to learn from data without being directly programmed by human programmers. It's one of the new methods which data scientists are using to solve complex business problems with large and varied data sets. This is exciting times for machine learning. It makes rapid advances, as we heard early on this morning from Attilia. The rapid changes to increasing computing power, the speed we can see, the advanced methods, and the unpredictable growth of digital data. Machine learning depends on data. Computers are fed data and instructed to look to patterns. So the more data they have available, the more scope there is for machines to identify these patterns or learn from the information that they are fed. So as more and more services become digitalized and knowledge is increasingly being put to the web, machine learning has the ability to produce even more accurate data. So what's the ML value for official statistics? The data science revolution has the potential to improve the production of official statistics and the indicators. Statistical organizations such as ONS, where I work for, are dedicating significant resources to explore ML values to their own systems. New technologies such as machine learning can enable statistical office to harness big data. For statistical agencies, we are particularly talking about non-traditional data sources, such, for example, as web scrape data, mobile phone data, and scanner data. Indeed, it's not possible to handle big data without ML. It's like big data is the oil, but ML is the refinery that produces useful products from this raw product. ML can also help to improve the efficiency of manual tasks and automate certain routine tasks. So most importantly, ML promises to help statistical office meet demands for outputs which are more relevant, more timely, and more usable to help governments set priorities, make better informed decisions, and implement better policies. So here are some of the areas where machine learning can be applied in the official statistical production cycle. This is the GSPPM, the General Global Business Process Model. We found it can help automate a number of manual repetitive tasks. It has proven benefits for a number of processing tasks, such as classification and coding, reviewing and validation, and editing and imputation. And let's look in more detail now in one of these areas. Coding and classification are essential to ensure data gathered from people or businesses are comparable nationally and internationally. But these processes are resource intensive, as we all know. often involving human experts reading responses and inciting codes them. However, with ML, this process can largely be automated. Human experts first work on a small subset of the entire dataset, and the ML is then used to classify the rest by learning from the patterns of experts' work. Such automated coding leads to faster release of figures, making them more valuable to end users. This is not only has potential cost savings, but it also frees up staff resources for higher value work. So on this slide, you see lots of international logos. So as statistical organizations gain expertise in machine learning, many found that the collaboration has been key to accelerating this development. So the UK ONS Data Science Campus, where I work, partnered with the UNECE, United Nations Economic Commission for Europe, based in Geneva, is leading its machine learning group we led it from 2019 to 2022. It was a platform for the statistical community to carry out research, collaborations, share use cases, and explore organizational integration issues and build capacity. 4 years of investment by ONS with the UNEC in building this ML community. Like 2018 was really like the setup year, and we started with about 10 to 12 members. And the last 3 years, from 2019 to 2022, we really looked at the implementation part. I mean, we gathered well over 400 members now from 30 different organizations, really across the whole world. We really traveled together on a learning journey. Sharing experiences of ML helped accelerate the research and development and gives us a realistic, informed view of what's required to harness the great potential of machine learning for statistics. The knowledge we've gained of ML in NSO Internet can help all offices transform and modernize their operations. So what we did, so we did knowledge exchange, we research collaboration and capability building. I'll just build the whole slide. We did pilot studies, we webinars, we shared use cases, we did coffee and coding sessions, we wrote newsletters and published a lot of information on the website. We had in-person sprints. The power of meeting in person is always really great. I mean, we had workshops in the UK, in Serbia, in UAE, in Brazil, and Indonesia over the last couple of years. We focused in the first phase on understanding the value add of machine learning and the quality issues, like the coding classification and imagery were very much the most popular topics. The second phase was more the emphasis on the importance of ML for handling big data and a deeper dive into how to integrate with statistical production processes. So the phase 3 was very much like a deep dive into big data. We looked at research collaboration on web scraping, AES data. We also did some further investigation in quality, looking at training data and model retraining issues. I mean, across the 3 years, what were the outputs? We ran over 40 projects and working groups. We produced many technical reports. We shared code and methods, ethics and quality frameworks, and we wrote some very active papers as well on organizational issues for the integration ML into production systems and how to help with that. And we archived all of our recordings, our use cases, and also the best practice discussions. Here you see some feedback what the different NSOs found by working collaborative across the group for the last 4 years. And this was presented at the UNEC high-level modernization executive board meeting in November last year. One of my team members was there, and we had so much feedback, and we just put a few comments there. A summary of why we invested and what we achieved. I mean, a place to explore and test ideas. Sharing of tried and test approaches helps speed the process, target resources, enable organizations new to ML to accelerate the development, address common production challenges, raise profile of ML among strategic decision makers, and building staff skills. So a lot of really positive feedback into this. Now I will look in a few examples, like kind of proof of concept. There's about 4 or 5 slides for this, so I'll just take maybe 2 examples, and the rest, of course, you can see when we share the slides. So this one is from Stats Poland, machine learning in the application area. What is it and how will it be useful? So using web scraping to produce more frequent statistics on the Polish property market. The first stage is all about experimenting with auto coding for different variables, kitchen type and security filters. So how did this project come about? Like organizations encouraging staff to really to search for new methods and new sources to get more timely, more relevant statistics. Knowledge and experience was gained in the machine learning group. There was like a whole expertise teams under the guidance of Dominic with the CPI colleagues. They established the web scrape data on real estate, and it would be useful for comparison on the rental market. But also two favorable conditions to help launch is like the experience of the ML, where Polish regional stat office worked on automatic classification, and also the establishment of a central office on experimental techniques. So we had kind of 3-4 different units working together on this. So what was needed? I had to set up an IT infrastructure, some remote service, some dedicated disk space, outside organization, internal web, version control of scripts, API connections. They acquire data. And of course, that's the key part of this. They had to do some data cleaning and to prepare validation rules. And then they had to apply some auto coding. But what's very important is the results. So more than 72% of the automated classified data with a probability of 95. That's high. It only took 1 week for 4 people to manually classify these two variables from like 6,088 out of the 8,881 non-duplicated adverts. So it really shows that with ML you can start seeing less errors, more time efficient, and it's very replicable. I'll just take another one here. So this one is from the IMF, the International Monetary Fund. So the aim for the IMF was really the ultimate goal was to build a tool that can be used by the IMF staff working on attributing codes to non-code indicators from country upload files and help speed up and automate this work from a user perspective. So having a solution that's easy to use requires minimal training. It's also close as possible to the current process is a key factor in the success of such a tool. And to facilitate, the team built an R-Shiny app, allowing the user to interact with the different functionality of tools and then generate predictions following the process shown below. Like we had first of all, a maintenance plan, consistently updating the training data with new data, predictably retrain the model data, then looking in improving the overall quality of the predictions, but also then improve the CTS classifications in the Shine API by allowing the user to review, accept, or reject. And also then override the assigned code by a model directly in the app. So the progress made is fully automated proof of concept. We created a package for ML. That's all available now on GitHub. We also have published an internal Shiny app for users to run the model and to predict codes. So the expected impact for improving business processes and outputs, and the current version hasn't been implemented, but we expect a considerable gain in time. We improve the quality of the assigned codes and free resources, allow staff to work on this with more analytical tasks quicker. So why did they find the work with the ML group beneficial? They played an important role because the knowledge and expertise shared from technical and logistical aspect provide a platform to present the work and feedback from the peers across the different organizations, and understand also what are the main machine learning challenges faced by other international, other international organizations that also want to really build the data science community. So I'll very quickly on the next two. So this one is from Mexico around auto coding, and the aim really was here to increase the quantity and quality of the encoded rigid automatically, which they use support vector machines. And so in the organization, they have project now codifying variables of occupation and sector of economic activity in different surveys and population and housing census, achieving to increase the quality and the quantity of records and code ultimately for household income and expenditure survey. So it would mean an improvement in the rest of the projects. So the last one is around the US workplace for injury. So the aim really for this is to to improve the quality and the efficiency of coding circumstances of work-related injury and illness collected by the Bureau of Labor Statistics. I mean, traditionally, 300,000 reports are collected each to survey of occupational injuries and illnesses. So they have to read through every category. So ML helped to build that chains. They looked at some primary data input, and then they fold the ML process. And this now is assigned to, so the occupation is assigned to, according to the SIC, the SOC, the standard occupation standard. So the data preparation didn't seem valuable enough. So the 6 classifications was assigned to each case based on the SOC. And what they did to the different models that they tried logistic regression, they tried support vector machine, variants of naive Bayes, random forest, and multi-layer perceptions, and many variations of convolutional and recurrent neural networks. The results showed 2 important findings. First, machine learning techniques like support vector machines and logistic regression can produce more accurate coders than naive Bayes. Second, these more effective machine learning approaches can also achieve classification accuracy similar to or better than those achieved by human coders. And that's an interesting one. So it can already receive higher results. So I talk a few minutes about how machine learning has potential applications for the NSO. So what did we learn? Number one, machine has many potential applications in the statistical organizations. The main ones are for classifying survey responses, handling big data, register data, and pilot study shows how ML can improve relevance, timeliness, and efficiency of official statistics. The potential of ML for official statistics is genuine and of huge importance. I mean, as seen on the web scraping team, ML is essential for tool for making used or web scrape data, which the statistical office are increasingly looking at new data sources. It's simply not feasible to do this manually, processing for type of data. Text classification and imagery classification were the most popular use cases in the statistical organization. And we also learned about some of the new applications in 2022, like predicting with survey response to select for follow-up questions. That was from the ABS. We're creating more evidence-based survey frameworks, and we also triaging multilingual customer inquiries. We also saw like use cases outside this usual application area, like the using of ML to select survey response to follow up. We looked at efficiency sorted to customer injuries. We assist samples by selecting companies that like to engage in particular industries, and this will continue. The second one is the machine learning has huge potential, but quality concerns needs to be addressed first. There are also legitimate reasons and concerns about the introduction of ML due to the rigorous quality standards, which are fundamental to the operation of official statistics. The drive to move forward with innovation needs to be balanced against a need to understand the implications for quality. For statistics, quality, of course, doesn't just mean accuracy, but also other dimensions such as timeliness and cost effectiveness. The third one, you see the picture of the iceberg there. The integration of ML into existing statistical products requires resource, strategy, and time. Integration in machine learning requires more than just ML skills. As with all the methodology and methods, you need, after the initial experimentation, it needs a supporting environment and infrastructure to scale beyond specific small group of experts. There are many resources available for learning how to write ML codes or run neural networks for text classification, but we don't yet have clear direction on how to best put an ML model into production with the complex organizational structure of a statistical office. This is the part of really time consuming and requires most heavy lifting. So next steps in the ML collaboration. In June, we have a workshop planned in Geneva. This is open to anybody. These representatives of the member states, the United Nations, and interested organizations are really welcome to come there. We asked participants to register by the 20th of May, so that's in a few weeks' time. Most of the work from the past 4 years is available online, so you can view this on the UNEC ML Group Technical website. We have their reports, we have case studies, we have meetings recorders, and we also got many slides on the website available, and you see the link there as well. So please log into that after this presentation. If you like more info needed, so we also talk about the UN Global Platform. So the purpose is working together to educate and to collaborate and develop new technologies to work with our new big data sources and methodologies. A platform that enables NSOs to access and process big data, particularly AIS and Earthization. Without having an own in-house IT infrastructure, you can make use of this. We also contains method, code, guidance, and use cases. We have the UN Learning Management System, the Big Data Competency Framework. We have the Majority Matrix, the curriculum, and the online training. And also we have lots of learning activities there, collaborative NSO projects, webinars, training courses, hackathon, and workshops. And of course, as you're all in Hangzhou, of course, we got the big regional hub that looks after the whole Southeast Asia area. So please speak to members there, and to members from the UN DESA group for the UN Data Science and Big Data group. So, in summary, data science innovations is transforming statistical work. That's a given. It's happening. ML is vital for handling big data and can help automate manual tasks, but it raises quality and ethical concerns, which we need to improve on. Statistical organizations have developed many use cases that demonstrate the value of ML, and also the focus is now on the challenge of how to integrate machine learning in establishing production systems. This is the end of my slides. Thank you very much.
This is the end of the session, and you can leave.